Alright, I'm just going to be doing a video here, just in case this helps anyone else. These are a set of SN-28B Dupont crimpers, or Chinese copy of Dupont crimpers. Basically, when I was first bought these, I was having problems crimping, so this is just the technique I use for creating the crimps. The reason why I'm doing this is because I'm making a sensor. I'm just basically making a sensor board for my home weather station, rather than having one wire connection and soldering anything. I've just basically soldered everything on the bottom here. All these terminals are joined up here, so now I have 20 connections for every point wired up. So obviously I've got terminal connections here, 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 and here. So that's 20 for each one. So basically I can have 20 different sensors using I2C just from this one board. And then basically I've just got to power them. I've just got to do VCC, ground, SDA, and SCL. And then that way I've just got to wire up these connections. So I'm using the Dupont connectors simply for simplicity, and then on the other end these will just get soldered directly onto the parts I'm working with, or been thinking about putting RG11 terminals. But so what I'm going to do now is create the connections. I haven't done anything yet, so strip the wire using any brand of wire strippers. Basically you only need one or two millimeters of cut off. And I've wrote a website article on my website about this. It's probably made a bit more sense, but basically if you're unsure how far to crimp these, the gauge, if you need to know what's marked on these, well, it's not marked on these, sorry, but you can get a general estimate based on the Dupont crimps. But roughly the amount needed crimp is about the same width as the actual part. So it's about the same width of this piece of metal here, and obviously if you insert it, you can see the rough length where it needs to be crimped onto, and the metal down there goes into the back, and there's like the Dupont crimp itself wraps around the metal on this part. It's a bit harder to see on the video here, but I'll show better on my website. But there's basically two parts. There's like this part at the top here which crimps onto the wire, and you got this metal bit here which wraps around the actual copper conductor. And then obviously what I'm using for this connection is I'm using BT spec CW1308 cable, simply because it's 4 pairs solid copper and it's just simple to connect to, and it's quite easy to work with as well because it's quite a small gauge. So I'm just going to go through stripping all these wires to the rough amount I need. Trying to make this video in real time just so you can see how long it takes us to make 8 connections for Dupont. And then obviously I'll post a link to me website article as well, just to make it easier for people who's a bit stuck on what to do. That connection there was actually too big, so it's all I'm doing is a copper wire. I know it's too big. You get used to the size of these when you do them anyway now, so I can get a pretty good estimate on how big I need to cut them just by looking at it. It's basically a couple of millimeters on each one, not too much you need. Helps if you use a good pair of wire strippers, like the ones I've got are fairly rubbish. But, there's one. So all I'm going to do is crimp 8 wires and then put them on the block. There's that one. So I think that's it there. So 1, 2, 3, 4, 5, 6, 7, and I'm missing one. I haven't done that one yet, so 8. Right, so I've stripped 8 wires there. Yeah, Dupont connectors come on as a male and female. This is the female version with the little square insert, and all it is, it just comes in a little tab. All you do is just bend it backwards and forwards like that, and it'll break off the tab eventually. So there you go, there's your little Dupont connector. Crimp is the technique which some people use. Some people have gone the full end, but I can't do it because I find it tends to slip out due to the size, and because I've got sausage fingers it makes it harder. So I just tend to do the approach of basically clamp it down to get some pre-tension, then I go from there. Now the Dupont crimpers on the end themselves, what there is there's a tiny little ridge about halfway down, which is where these pointy tabs lock onto from the insulation part. And then what you do is you basically slide it into the crimps, face that, so pointy end into the ridge, gets to about halfway down, and then crimp it just enough to get a bit of tension on it. So as you can see on the other side of the crimp, it's sticking out about 2/3 of the way. Now you push the wire through the crimp, and then what you need to do is crimp it on the other edge, but you don't actually push the crimp too far out, because then it'll go past the insulation. It'll go past the actual metal part, which is where it crimps onto. And what I was finding, I was crimping it too far and damaging the actual locking tabs, so it wasn't staying in place. So what you end up doing is you just get the copper, and all you do is you just crimp it, which when you're crimping it, the actual copper sort of runs a line with the edge of this part here when you hold it. And if you see any point beyond that, it's a bit too far out. But what I do is crimp it once. That creates the solid connection. It bends the metal around the copper, and then I put it in about halfway again. I don't know if I'll see it on the camera here. I've got some photos, but I put it in about halfway again towards the end, and all I do is I just crimp it again on the connector, simply to bend the wire tab around the wire tabs around the insulation. That's one connector made there. So I'll just go through doing all the rest now. May as well get these. That's the wrong connectors. That one. So I'll get the rest of these off. There's 1, 2, 3. These proper parts, I think there's normally meant to be a thing which feeds them through to a machine which actually cuts the tabs, but you can do this. 4, 5, 6. How many is there? 1, 2, 3, 4, 5, 6. And then you've got 7. So we'll put all our connectors down there. Same approach again. I'm not really going to repeat the pattern over and over, but it's basically face down into the crimp. Get a small bit of pre-tension first. Push your cable through, and then retract it a slight bit just so the metal of the copper goes to the edge of the crimp. Crimp it once to bend the tabs around the metal conductor. Push it a bit through. Crimp the end so it crimps the connection. And then we'll do that. Put that there. Finish one. Repeat. So I'm going to do this another 6 more times, and then insert into the connector and test it from there, and then make sure it's alright. I think that was a bit too far. That no, it was alright. The only problem I tend to think you get with these is due to the diameter of the wire, it's a bit small to see, so sometimes it can be hard. So you might find it for some people who have hard seeing things, or simply working under a microscope, because it's quite hard to see. You might find a bit of magnifying glasses might make it easier, or having a little magnifying lens at your desk while you're doing these, and then that way it just makes it a slight bit easier for when you're working on it. Saves you the hassle of the headache of trying to see if you've got it in the right place. You can just simply wire it on then. So to say, of it, anything I'm describing on this video, I'm going to have my website article, because I prefer to work through pictures rather than audio, because I find it easier to describe what I'm working with and for people to see what I'm looking at, because it's I'm more of a visual representation when it comes to training than actually videos. So how many kills that? 1, 2, I think it's about 6 there, so another 2 more. saying, this is just the technique that I'm using, because obviously I'm working what I find the easiest way, and once I discovered the way what works for me, this is what I've been starting to use now, because I simply find it easier. Been doing it since last night. I was basically playing around just to identify methods what work, and then once I get one, it works fine. So there we go. There's 8 connectors made. Now, obviously, your header pin, or your header connector rather, goes in. There's only one way it can go in. Basically, you have the end where your pins come through here on the other end, and then you've got a square bit at the end where you push your plugs in. Just for reference, this bit, it's a bit hard to see in the light here, but this bit, you have a where you can see through the gaps, and you see a little connector there. You can see them gaps there like that. That's the bit, that's what needs to face up when it's inserting new like that. And obviously the crimped end, where you crimp the connection, the bit where it pushes down on the insulation, where you can see the actual insulation crimp, that bit goes face up. Then you insert it into the little gap, and you should hear 2 clicks. There's generally a quieter one, and then you should hear a slightly louder one as you push it in. There's 1. There's 2. And then that connection should now be firmly established. You should generally give a tug test, but it's there we go. So we'll just go through pushing all these in now. There's 2. There's some of these, when you insert them as well, you might actually put them in the wrong way, but generally you'll see when it's assembled, because it's they won't look right. But if you insert them the proper way, both tabs should lock in. That one there, I don't think you're inserted. Oh no, I did. So these are probably not the best connectors, but it's the circuit I'm working with for me home is just a basic electronic circuit anyway, so it doesn't need to be perfect, it just needs to work, which obviously I believe it is. There's that one. That one. See that connector I didn't properly insert. That's why it's come straight out. Question is, have I damaged the connectors on it? We'll find out. Try it again. Nope, it's in. Right, so all I'm doing now, still not happy with that connection. All I'm doing now is just strip the wires on the end of here, just to do a quick conductivity test with my multimeter. Not bothered about the look at the wires, because I'm not, what the hell? Because all I'm gonna do is, I can get this one fucking wire to trim, but whatever. All I'm gonna do is trim the wires, do a conductivity test with the multimeter, just to make sure we've all got a connection. Where's that other one gone? That one there. And then that'll be the board. That'll be the connector built. So all the wires is stripped, just basic copper ends. My board, my little board what I've got built. Face it the right way around. So there we go. So connectors on, as you can see. Obviously, like I say here, all of it's joined underneath by solder, and then it's just a case of get the multimeter, switch it on, put it in diode conductivity mode. Might not see it on here, but I've got a Hilco on, so on there it looks like a little triangle arrow, or sometimes it has a music symbol on it. But obviously, when you put your leads together, it sounds like that. So if I go through touching all these leads, which was that one if I remember right, if I go through touching all these leads, it should make a beep on each one. So that was me. I pulled off the multimeter lead without realising. That one there. Yep, just because I've got a crappy buzzer. That one, that one, that one, and that one again. There we go. So all of them have got a solid connection. Now, in total, I've only got 8 connections on each one on here. So, but the way I've done the board is there's another 8 pins, well, another 10 pins on the bottom and another 2 pin spare. So there's a total of 20 connections I can do for this board. And because I'm using it with I2C, I only need 4 lines. So there's I mean, I've put in some couple of extra ones there in case I need to wire it to in case I need to do cable select or anything like that. So these are just spare ones, but basically the intention is to use just these 4 and then wire up 10, so I can basically have a total of 20 sensors on each one, theoretically. Hopefully that should help anyone on this video, and I'll put a link to my website article. If you need any further questions, please comment.